we are continuing with the topic of highway capacity analysis. So we said there are three types of uninterrupted flow facilities. We discussed two of them, okay, which was the freeways and multi-lane highways. Okay. The third one is this one, the rural two-lane highways. Okay, and we already discussed why it is only for the rural areas, because in urban areas, the two-lane highways are used in commercial zones and in residential zones where they cannot be uninterrupted. Okay. Now I've loaded two editions of the textbook, and this is from the old edition. Okay, because in the new edition they did not put it. Okay, so and they did not change it as well. Okay, so two lanes, we know, one lane for each direction. So if you have to pass, you will pass from the other direction. Okay, you have to overtake, you will overtake from the other direction. And then in that case, the side distance becomes an important criteria. Okay, because now we are going into the other direction, so you must have enough side distance to complete the passing. You have to see the car from the other side as well. Okay, and secondly, you will only do the passing if the other side is free. If the other side is also jam-packed, you cannot do the passing. Okay, and this is why we discussed in the last chapter that both lanes at the same time cannot reach the full capacity. If one of them reaches 1700, the other one cannot reach 1700. Maximum for one lane is 1700 for two-lane highways. The other one will always be less than that. This is because this is the reason. Okay, because if this one is jam-packed, in order to get this one to the full capacity, some people have to pass, and they cannot pass from the other lane. Okay. So and I mentioned this one as well, that traffic in one direction has an impact. Okay, and we discussed it in the last chapter as well when we were discussing the free flow speed and the effect of the work zone. Okay, so there was a factor for lateral clearance, right, in both cases. So lateral clearance is for an object. There's an object which is beside the road, and we said it affects what? Free flow speed or the capacity. Now, if an object which is beside the road can affect free flow speed and capacity, then obviously cars moving beside you will obviously affect you. Okay, so one side has an impact on the other one. Okay, so two-lane highways can be used in the periphery. Fringes means boundaries, outside areas. Okay, fringes, boundaries. They can be used in agricultural regions, resource development. You have some mining sites somewhere. Sometimes they put these tech industries and these things. So these are resource development areas, or you can have, in some cases, military posts, okay, or something like this, which is very far. Okay, so again, all the examples mainly for the areas which are outside the city. Okay, so according to Highway Capacity Manual of 2000, there are three different types of two-lane highways. So now we are talking about the types of two-lane highways. So they call it class 1, class 2, class 3. Class 1, class 2, class 3, the types of two-lane highways. So class 1 is for high speed. Class 1 is designed for high speed. In order to maintain the high speed, so the speed is directly linked with mobility, your ability to move. High speed means your ability is higher. Okay, so in order to maintain high speeds, you need to provide these features. The geometry of the road should be gentle. The slopes should be low. The radius should be bigger. The width should be more, and so on and so forth. Okay, so this is what they are calling as gentle geometry, so that you can allow for high speeds. Okay, these types of highways are used for traveling between the cities, from one city to the other. Okay, they may be primary arterials. Okay, maybe even within the rural area, within a small town, they can act as an arterial, or they can be daily commuter routes for some people who are living outside the city. Okay, and not here, but in countries where you have very highly populated cities. For example, UK. You go to UK, there's London. Okay, so London is very expensive and very congested. Okay, you go to France, that's Paris. Okay, so these cities are very congested. Even in Pakistan now we have Karachi, but our problem is even if you take a house 10 kilometers outside the city, we still call it Karachi. We have big hearts. Okay, so even if you go to some other country, we will still call it Karachi. Okay, you search on Google, you find many places called Karachi here. Okay, Karachi, hotel and restaurant, so on and so forth. Okay, so people live outside the city because of the congestion, because of the housing prices and the expenses. So they live outside, but their work is inside the city. So they come on daily basis. For us, we have the example of people coming from Saudi. Some of the people who live here and work there are the other way around. Okay, but obviously it's not a 2-lane highway. The cost is not 2-lane, but this is the type of thing they are talking about here. So daily commute for people who are living just outside the city, but they work within the city. Okay. So again, coming back to the concept of how do we maintain high speed. First of all, the geometry of the road should be gentle. More width and radius and gradient and so on and so forth. Then we need other features as well to maintain high speed. For example, shoulders are very important for maintaining high speeds. Shoulders provide clear space. Shoulders provide a space to park your car if something is wrong. Okay, without shoulders, becomes very dangerous and people will eventually slow down. Okay, so there should be shoulders, maybe roadside recovery areas. So these are unpaved areas, open areas. In case of an accident, instead of the car is out of control, you just move towards that area. Okay, so you call it a recovery area on the side of the road. It's beside the shoulder. It's an unpaved. Shoulder is definitely kept paved here because of the speed, but then there is another area beside the shoulder which is unpaved but clear. You can still go there and park your car. Okay, markings, signs, very important. All these things which I mentioned in the last 2 points, all of them are very important for maintaining high speeds. Okay, for some of them we already discussed the effects. Then we have class 2 highway. Class 2 highway is for low speed. It's a 2-lane highway, uninterrupted flow facility, but it's designed for low speeds. Okay, so where can we use them? Access routes. Okay, you have some facilities which are outside the city. Okay, and you want to go there, like big industrial complexes, ports. Okay, there are countries in which ports are far from the city, so they serve as access route. Access route means a road which is going to a specific facility. In some cases, it can be an airport as well. Airports, ports, these are the facilities that are normally built outside the city. Then cities grow and they come inside. Scenic and recreation routes, you're going to a beach. Even here, you go towards the Zallaq area, you will see these types of highways, 2-lane highways. Okay, so these are recreation routes, obviously. Okay, but they cannot be primary arterials because then you need high speed. Not arterials, you have high speed and high volume as well. Okay, they can be routes through rugged terrain. I mentioned in the no, not here. So they are mountainous areas. Okay, where you have to go to a specific town, and the route towards that town is very rugged. Rugged means dangerous. Mountains, rivers, these sort of things. Okay. So they basically serve the access needs. They are providing the connection. Access means they are providing the connection. Their main idea is not to go at high speed. Their main idea is, okay, if I don't have this road, then I cannot reach this facility. Okay. So low speed operation. So it may not have any passing opportunities. Okay, the side distance will be limited, and especially because of these things. When you are going towards recreation routes, rugged terrain, and so on and so forth, normally maintaining high side distance, long side distance, very difficult because the construction will be expensive then. In a mountainous area near a river, or something like this. Maintaining long side distance very difficult. Okay, so they have low speed and they may have less passing opportunities. Okay, so obviously the things which we mentioned in the previous case to maintain high speed, they are not here because we don't want to maintain high speed or we don't have to maintain high speed. Then we have class 3, which is given by Florida Department of Transportation. So this is the only department which came up with class 3. So it's not used everywhere. Okay. So this class can actually be in the more developed areas. So the previous 2 classes were outside the population, right? Outside the populated area. This one can be inside the populated areas. Okay. So it can become the main street of a small town. Okay. For a small town, it can be the main street. Main street means a street which takes you from one corner to the other. Okay, or which carries most of the volume of that town. That's a main street. Okay, okay. So it has reduced speed limit, tight restrictions on passing, and more roadside driveways and unsignalized junctions. Okay, so we have discussed for multi-lane highways as well. If we have unsignalized access, we just consider them access points, right? We don't consider them as intersections. So it's we consider uninterrupted. Okay. So why we have lower speed limit and tight restrictions and this? Why? The answer is on the slide. Why? It's within the city. Why isn't it within the developed area? So you cannot have a main street which is going through the area and you put a speed limit of 100 kilometers per hour on that. It's very dangerous. Okay. It may include recreational routes. Okay. So going from the town to a recreational route to a picnic point and so on. The other design standards, okay, you cannot see the last one, that is for rural arterial. Okay, so you can see how much volume they are supposed to carry and how much speed you can give on the basis of volume and terrain. Okay, so when you are designing it for higher volume, the speed is higher. Now remember, this is the design speed. Design speed will be higher. Okay, because obviously when will you get higher speed? When the volume is 200 or when the volume is 2000? 200, right? So why they are giving higher speed here? This is not the speed of the road. This is your design speed. So the road which carries more volume should be designed better, right? So how do you make the road design better? By using a higher speed. Okay, so this is a design standard, not the speed of the road which you will find in the peak hour. Okay. So this speed will be found on the road in which conditions? When it is? Which level of service? A. And level of service, then the speed is, what do you call? The speed in level of service A? Free flow speed. So these are basically the free flow speeds. Okay? They are the free flow speed, not the actual speed of the road when you have this much volume. So free flow speed must increase so the road becomes better in design and can handle more volume. Got it? Okay. So we have rural, local, rural collector, rural arterial. Okay. But we are discussing about classes, right? Is it class 1, class 2, class 3? Where are the classes? Class 1 arterial. Class 1 arterial, you already said that, right? Class 1 is arterial. Okay. Class 2? Local. Local? Collector, because for scenic views and. Yeah. Collector can be 2 or 3 both. Okay. And then rural, local road is class 3. Local road is within the developed area, right? Local road is within the developed area. Okay. Class 1 we already said can be an arterial. Collector, sometimes 2, class 2, sometimes class 3. Okay. So we don't have design standards for each class, but they are applying to the classification of the highway itself. Okay. So this is what they are saying. There are design standards for speed then, again for each of those types. Okay, this is one for rural local road, rural collector, rural arterial. Okay, and you have the gradient. Okay, so you can find out the gradient from here. So you select your speed, you know the type of highway, the type of terrain. So for example, I am designing a rural arterial. Okay, this one is easier to see. Rural arterial, okay, fine. So rural arterial, my speed is 60 miles per hour. So this is the graph, and my speed is 60. So I'm here. Now my terrain is, let's say, rolling. Okay, so for rolling terrain, I have this line. Okay, so 60 miles per hour. I go to rolling terrain, and I have my gradient. How much should be my gradient? Okay, so these are couple of things related to their design standards. The previous table was giving you design standard of speed. This one is giving you design standard for the gradient. Okay, capacity and the base conditions I mentioned in the last chapter as well. 3200 total. Out of 3200, one direction can go up to 1700. And when one direction goes up to 1700, the other direction cannot go up to 1700. It can only go up to 1500. Okay. Why? Because of the passing restriction and the effect of the other side. Okay. So we discussed about base conditions, right, in the last chapter as well. If you meet the base conditions, then what happens? You get the right free flow speed. If I meet the base conditions, these are the base conditions. There were some base conditions for freeways and multi highways as well. If you reach these conditions, what happens? Huh? If you don't meet these conditions, what happens? If, for example, I'll make it easy. If the lane width is not 12 feet, then what happens? Where did we use the lane width? What we were doing with the free flow speed? Because of the lane width. What was happening with the free flow speed because of the lane width? Huh? But there was a factor, right? There was a factor. Okay. So if you don't meet any of these conditions, then there are adjustment factors. Okay. So base condition means then you don't need any adjustment factor. So base conditions are, you can see here, the same: 12 feet lane width, 6 feet shoulder, level terrain. Okay. No heavy vehicles, so we are calculating everything in passenger cars. 100% passing side distance available. So you can do the passing if there is no traffic, obviously, from any point of the segment. 100% passing means passing side distance available on any point of the segment. Okay. 50-50 directional split and no interruptions. Obviously, you know that it's uninterrupted, right? Okay. The last one is no interruptions. Obviously, we are discussing uninterrupted flow facilities, so no interruptions. 50-50 split. We said one side has 1700, the other side has 1500. Where is 50-50? These are liars, right?
Yeah, so some other direction.
Yeah. So 1500 in one direction, 1700 in the other direction, right? 3200 capacity. This is what they were saying, right? Capacity is 3200. 3200 means 1700 one direction, other direction 1500. Now they are saying have a 50-50 split. What is this?
The actual should be 50-50 about what?
Yeah, the actual traffic. Huh? The actual traffic is 50-50 or should be 50-50 for a base condition. Okay. So actually on the road you may not have 3200 passenger cars per hour. You may have only 2000. So the base condition is these 2000 should be 50-50. Okay, got it? For measuring the level of service for two-lane highways, we need to calculate two parameters. One of them is ATS, three parameters, but two of them are related to each other. We have ATS, average travel speed. We have percent time spent following, and we have percent free flow speed. Average travel speed, we know that, right? Average speed of the cars, average travel speed of the car for the segment, we know that. Okay. Percent time spent following, time spent following is that time during which your spacing with the car in front of you is so small that your speed depends upon it. I'm so close to the other car, I have to respond to each and every speed variation which he is making. So if that car slows down and I don't slow down, then there is definitely an accident. Okay, that car stops, I don't stop immediately, there will be an accident because there is not much time or spacing between us. Okay, so they are giving me a limit. I think there is a limit here. When the time interval between you and the other car is 3 seconds or less, this is considered too small. Okay, too short. Okay, especially when you're driving. Okay, so the other car stops. How many seconds you have to stop? 3 seconds. 3 seconds is nothing, right? You put your foot on the brake, 3 seconds are gone. Okay, so this is considered very, very short. So if your headway is less than 3 seconds or less, this means you are following the other car. You're following the other driver. So the amount of time in which your headway was less than 3, this is percent time spent following. So you draw for 10 minutes. Out of 10 minutes, there was 1 minute in which the headway between you and the other car was 3 seconds or less. So 1 out of 10, 10%, right? Percentage time spent following, yes, 10%. Got it? Okay. The last one, percentage free flow speed. We know free flow speed. We know free flow speed. And we know one more speed which is given here. What? Average travel speed. Which one will be higher? Free flow speed will be higher, right? So percent free flow speed is the ratio of ATS upon FFS. Travel speed upon free flow speed. Okay. What is the percentage of free flow speed you are still maintaining on the road? Okay. Yeah. So we need, in some cases, one of these parameters. In some cases, we need 2 of these parameters. In some cases, we need only one of them. Okay. So what are the cases? You can see them here. Okay. So we have 3 classes of highways, right? If you have class 1, that is the dangerous one. So you pray that it doesn't come in the final exam. And I will pray as well. Okay. Let's see who beats who. So for class 1, you need to calculate 2 things: ATS and PTSF. ATS, average travel speed; PTSF, percentage time spent following. Okay, and this is what we will do with an example. Okay. So for class 1 highway, the level of service depends upon 2 parameters. For class 2, it only depends upon percentage time spent following. For class 3, it depends upon percentage free flow speed, PFFS. If I give you class 3 highway, you just calculate this thing, and then you can have the level of service. If I give you class 2 highway, calculate this thing, and you have the level of service. If you have class 1 highway, then you calculate this, and then you have the level of service. Okay. Now let's say ATS is 45. Okay. Let's say ATS is 45, and PTSF is 70. Let's say. Okay. ATS is 45 and PTSF is 70. No, I'm saying names. Okay, 50. Let's say ATS is 50 and PTSF is 70. ATSF 50, I'm here. So level of service, C. PTSF 70, I'm here. This gives level of service, D. So I'm having two different values, right? So which one will I pick? The worst case. Okay, we will pick D. Okay, so most of the times it should direct you towards one value, but if it is for two, one criteria is going into one value, the other one is going to the other value, then you have to go for the worst one. Okay, free flow speed for the two-lane highway, same thing as for multi-lane highways and freeways. So again, you can go and measure it. You can go and measure it. Now for freeways and multi-lane highways, they give us a flow up to which the conditions are considered free flow, and you can measure the free flow speed or the spot speed. Okay, and that was 1000 vehicles per hour per day. For this, the condition is slightly lower. Okay, because two lane, but in highways have more lanes, right? So even with more cars, you can still have free flow. But two lane highways are smaller, narrower. So for this, the free flow rate is 200 passenger cars or less. Okay, for both directions total. Okay, so on two lane highways, free flow speed can be measured up to a point when flow is 200 passenger cars per hour or less for both directions. Okay, if it is more than 200, it's not free flow. Okay, clear? Now, so for example, you went to the freeway, you went to this two-lane highway, and you measured the flow. It was more than 200. But this is the only time you have to measure. You cannot come back at some other time. Okay, so what should I do then? I still measure the speed. Okay, if the flow is more than 200 passenger cars per hour, you can still measure the speed, but then you have to use this equation to calculate the speed. Okay, so if the flow is less than 200, whatever you measure is your free flow speed. If the flow is more than 200, you measure the speed and you put it over here. Okay, so what do we need here? To calculate free flow speed, we need the speed you have measured, whatever you measured. Okay, the mean speed. Okay, flow rate, which is flow rate passing through the road when you are measuring the speed. Okay, so VF is something more than 200, right? You apply this equation when you measure the speed more than 200. So VF is something more than 200 at which you measured what? SM, the mean speed. And FHV is, we know that, right? We have an equation, we have a table for EHV and so on. You don't know? And if you are lazy like me, then we have another equation. So you don't do anything. Just calculate it like we did for freeways and multi-lane. So there is no measurement from the road here. In this equation, we are directly calculating the free flow speed without collecting any data from the field. Okay, so now we have three options to find out the free flow speed of two-lane highways. You can collect it when the flow is 200 or less. That is your free flow speed. You can collect it when the flow is more than 200. Then you calculate the free flow speed. Or you don't do anything from the field, just use this equation. So in this equation we have BFFS, which is base free flow speed. Then we have factor for lateral clearance and shoulder width, for lane and shoulder width, sorry. Lane and shoulder width. And then we have factor for access point density. We have used it, right? FA, we have used it. And yeah. So they have given us a range of BFFS for each class of the highway. Okay. So for class 1, 50 to 65 and so on. Okay. Access point density, we already mentioned it for the multi-lane highways as well. It's the same definition. The factors, okay, the first stable factor for lane and shoulder width. So it's a combined factor. So you cannot use the factors which we had for previous emerging hybrids. Because it's a combined factor. There it was only a lateral clearance separate and lane width separate. Here it is combined. Okay. So you have the shoulder width and you have the lane width, and these are the factors, and then this is a factor for access point. Okay, very similar to what we had. Yeah, it's the same table actually. The same table which we use for multi-hybrids. Okay, and what was us? Yeah, BFFS I gave you the range. Free flow speed, 2-lane rural highway segment in rolling terrain, lane width 11 feet, 2 feet shoulder, access point density 30 per mile, base free flow speed is 60. Okay, so it's very simple. Free flow speed 60, the base, minus the shoulder for access point and lane shoulder width. So lane width 11 and shoulder 2. Which factor? Lane width 11, shoulder 2 feet. Which factor? 3. Okay, you have to look here. There is an equal to sign here. Okay, I just forgot something. Anyways. Okay, so free flow speed $60, then the factor for lane and shoulder width 3. Okay, so we are talking about this one, and the factor for access point density. Access point density was 7.5. So this is the factor. So minus 7.5. So total is 10.5 then. So 60 minus 10.5 is how much? 49.5. Okay. Any questions? Yeah. Yeah, after you find out the free flow speed, we find out the flow rate, right? This is what we did for multi-highways and freeways as well. Flow rate, we have this equation, V is volume. Then we have peak hour factor. Then we have factor for heavy vehicles, and we have another one, factor for gradient. So there was no factor for gradient with multi-highways and freeways, right? So this is the only thing we are using here, new. But there was something else. What was it? Number of lanes. Here the number of lanes are 1 each. So volume is taken for one direction. Okay, so one direction, right? Okay, because both directions cannot have the same volume. You cannot divide them equally. Okay, so that's why we don't see number of lanes here. Now, either you are calculating average travel speed, or either you are calculating percentage time spent following. Okay, average travel speed or percentage time spent following. Okay, if you have class 1, you have to calculate both. If you have class 2, you only calculate percentage time spent following, PTSF. If you have class 3, then I'm using this factor, PFFS, percentage free flow speed. Then what should I need? What do I need? ATS again. Okay, so in all 3 classes, you have to calculate ATS or PTSF, or in class 1 case you have to calculate both. Okay, now the factors which we are using, so we are using, for example, the factor of gradient. The factor of gradient depends upon what you are calculating. Okay, are you calculating ATS or PTSF? Okay, ready now? I'll take you on a roller coaster ride of tables, lots of tables. Okay, what do we need? We need flow rate. So flow rate is volume upon peak hour factor, right? Okay, so we need flow rate here, and then you need to know what terrain you have. If you have level terrain, then it doesn't matter what you are calculating. Are you calculating PTSF or ATS? The factor will remain the same. If you have rolling terrain, then we have a column for ATS and then we have a column for PTSF. All these values are the gradient factor, remember. So if you are using gradient factor or the flow rate for ATS calculation, rolling terrain, you will use column number 3. If you are doing it for calculation of PTSF, you will use the last column. Got it? Okay. But we know the terrain is not always level and rolling. In some cases, we have gradient as well, right? So there should be some FG factor for gradient as well. This is the table. So you don't have level or rolling, you are calculating FG. Okay, then you will use this table if you are calculating ATS, average travel speed. And then there should be another table for calculating PTSF. Okay, so there are 3 tables. One for general terrain conditions, which is this one, and 2 for gradients. One for ATS, one for PTSF. Got it? Okay. Then percentage time spent following is calculated using these 3 equations. The first equation for calculating the PTSF, and then we need a base percentage time spent following, which is from the second equation. Okay. So in this equation, I need, you can see I need A and VD and B. Okay. I'm talking about the second equation. Now VD means what? VD means flow rate in your direction. Flow rate in your direction. And then if you go to the first equation, you see V naught as well, right? The flow rate in the other direction. Okay. They will use it in many equations. Okay. So VD means your direction flow rate. V naught means flow rate in the other direction. Okay. So we are taking BPTSF here. Okay. I need A and B factors. I will show it to you. And I need factor of no passing zone. Factor of percentage no passing zone, FNPP. Okay. So what was the base condition? The entire segment is passing. You have enough side distance available on the entire segment for passing. Okay. So if it is not, okay, then you have a factor for this adjustment factor. This is the equation for calculating ATS, and again D is for what? Your direction. Okay, and again we can see here we are using VD, flow rate your direction, V naught flow rate opposite direction, FFS free flow speed, you already calculated or corrected it. Then we see factor of no passing zone again, but this one is for calculation of ATS. Okay, so no passing zone factor is different for ATS and PTS. Okay. And now we have discussed so many factors, right? Factor of no passing for ATS, factor of no passing for PTSF, factor, and then in this equation there was A and B as well. Look at the second equation. For all these factors, we have tables. For all these factors, we have tables. Okay, like I said, there are like 10 million tables. Okay, and you will ask me about, do we have to memorize it? I will say yes. Why are you looking at her? She already memorized it. So we will use these tables. If I keep on just telling you these are the factors and this is table, it will not stick. Okay. So after the break, we will do one example of class 1 highway. The class 1 means we will calculate each and everything. Okay. And this is for both directions. So you will have like a practice. You can do the practice for the other direction as well. Okay. So, but keep in mind, we have these equations. These are the main equations. So if you have ATS and PTSF, you can calculate level of service, right? Okay. The factors, there are tables. There are no equations for the vectors. Okay. So tables we will look at when we are doing the example, so that it becomes easier to remember. Clear? Okay. So on when next year.
Tuesday.
Tuesday. So Tuesday we'll do an example. We'll start with an example. Okay. We'll use all the equations and the factors. Okay. Thank you for coming.
Thank you.
Okay. Welcome.